Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. This is the question. In the sketch alongside the graph of y is equal to first derivative of x is shown. So the first derivative graph we got x-intercept 1 and -3 and the y-intercept -4. What is the gradient of the tangent to f at x equal to 0? This is the parabola quadratic function. So you're looking now the gradient of the tangent to f, which means the cubic graph. So at x equal to 0. So we need to visualize the first derivative graph and give the answer. So at x equal to 0, the answer will be -4. Y value is -4. Remember, I told you the y value on the graph of the derivative is equal to the gradient of the original function at any given x value. So y value we got -4. So by the f, this is gonna be a tangent, because that specific point, which is x equal to 0, at that single point the gradient is -4. Y value is -4 here, and this is a y value -4. So that's gonna be the gradient of the original function at that specific point, at that single point. Must remember, the gradient of the original function at a single point is the same as the gradient of a straight line that just touches the curve at that single point. This is called the tangent line. So obviously that's only touching once, so only that specific point at x equal to 0, and that will be equal to -4, because the y value of the is equal to the gradient of the original function at x equal to 0, which is going to be -4. So the answer going to be, so the part A answer is going to be a -4. So the part B, write down the x coordinates of the stationary point. Stationary point or turning point is the same thing. So the x-intercept of the parabola is the turning point of the cubic graph. So which is going to be now x is equal to -3 and x is equal to +1. Now the C part, the question says, what is the coordinates of the point of inflection of f? So you're looking the point of inflection of cubic graph. So we need to find the point of inflection of the cubic graph. So we take the midpoint of these two x-intercept of the parabola. That will be the point of inflection of the cubic graph, because the midpoint of these two x-intercept will be the turning point of this parabola here, and the turning point of the parabola is point of inflection of the cubic graph. So therefore x gonna be equal to -3 plus 1 divided by 2. The answer will be -1. So here is gonna be a -1. So the midpoint of the two x-intercept, -3 and +1, will be the turning point of the parabola, and the turning point of the parabola is point of inflection of the cubic graph. So therefore answer is x equal to -1. So the D part says, what is the gradient of the tangent to f at x equal to -2? Now x equal to -2, now is another tangent, this one, x equal to -2, the graph, which is a cubic graph, only touching once, only at x equal to -2. So we're looking now at that specific point at x equal to -2. So what is the gradient of the cubic graph? Now we need to visualize the first derivative graph which we have in front of us, and we have to give the answer. But remember, earlier we found axis of symmetry, which is turning point is here -1, and you must remember this is the axis of symmetry also, because I'm going to draw the line here. This is the axis of symmetry also. Why? Because divide the parabola into two halves. The parabola is even here, half laying left hand side, half laying right hand side. So the parabola is symmetrical, even. So this is the axis of symmetry at x equal to -1. Now, so we need to know find the uh, at x equal to -2, we need to find the gradient of the cubic graph. So obviously we need to look the y value in the first derivative, which we have -4 here. Have a look here. So this is the y value. Y is equal to -4. Horizontal line parallel to x-axis. So the y value is -4 all the way. Now, so we know at x equal to -1 also y value is going to be -4 here, because all the way here x going to be equal to -1 all the way there in the horizontal line. This horizontal line, this is a horizontal line. So y is equal to -4. Now we're looking, if we take the midpoint of, we need to find the x value. We want to make sure that at x equal to -2 the answer going to be -4. So we take the midpoint. We don't know which is the x value, so we take the midpoint of these two. X plus x values here 0, x plus 0 over 2, and so the midpoint of x and the 0, which we don't know the x, is going to be -1, because this -1 all the way x is equal to -1. This is the axis of x value is equal to -1, because this is axis of symmetry. So is equal to -1. So you cross multiply, x equal to gonna be equal to -2. X gonna be equal to -2. So which means there is here's x value -2. You want to make sure the x value is -2 here. So now at x equal to -2 here, also y value is gonna be -4, because all the way y value is -4. So the x equal to -2, the y value is gonna be a -4. So here -2 at x equal to -2, you can see if you draw horizontal vertical line, so the x value is gonna be a -2 all the way here, x value -2, but the y value is gonna be -4 at this point here. So this is the vertical line, the x value is gonna be -2 here, and the y value is gonna be a -4 at this point. So therefore first derivative of -2 is going to be equal to -4. So therefore the first derivative is going to be equal to -4. The gradient of f cubic graph at x equal to -2 is going to be a -4. Now we begin with part E. Question say for which values of x is f? First part increasing, second part decreasing. Quite interesting question. Now must remember f is increasing when first derivative is positive. So the cubic graph is increasing when first derivative is positive. So the first derivative is positive, we now need to see above the this is the first derivative graph. So above the x-axis here, the graph is, the first derivative is positive. So above the x-axis, the first derivative is positive. So this is the x-axis, above the x-axis. So this is above the x-axis, top is above the x-axis, bottom is below the x-axis. So above the x-axis first derivative is positive, below the x-axis first derivative is negative. Now, so f is increasing when first derivative is positive. So which means therefore the first part, therefore x equal to or less than -3. Must remember, whenever we say f is increasing, cubic graph is increasing, the turning point is included. So this is the x-intercept of the first derivative but turning point of the cubic graph. So the less than, you can see the less than -3 all the way less than, when the any value, because the parabola down is, the parabola is locked here. Can you see the parabola is locked here? So the less than -3 all the way value this side, less than -3, the graph will go up, 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 up. So the less than -3, the graph is increasing. And now we go to the second side. Now we go to the right hand side. Greater than 1, x greater than 1, all the way the graph is positive. Or x greater than 1, the graph first derivative is positive and the cubic graph is going to be increasing. Second question, where is f is decreasing? So f is decreasing when first derivative is negative. So the first derivative is negative between -3 and +1. You can see all the way the first derivative below the x-axis is negative. So therefore the f is going to be from the turning point, the f is decreasing. So -3 turning point will be included, because -3 and +1 are the turning point of the cubic graph. So -3, between -3 and +1, the graph f is gonna, the cubic graph gonna decrease. Must remember, -3 and +1, they are the x-intercept of the parabola but the turning point of the cubic graph. We need to include the turning point whenever we talk about f is increasing or decreasing. The turning point are included. So the -3 and 1, they are the turning point of the cubic graph. So the cubic graph will decrease, f is decreasing when first derivative is negative. So the first derivative is negative between -3 and +1. So f is decreasing between -3 and +1, -3 and +1 are included. Now the question number f, is f concave up or concave down at x equal to 0? Now this is the first derivative graph is left to right. We need to read the graph left to right. The graph is decreasing, 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 decreasing. By this turning point, increase, increase. Remember, turning point is -1 here, no? Increase, increase, increase. So where is the graph is decreasing, the gradient is negative. Where the graph is increase, the gradient is positive. Now the gradient of first derivative is positive. You can see at x equal to 0. So x value is 0 here. The gradient is positive because you can see the graph is increasing. So the gradient is positive. So which means the second derivative also gonna be a positive. So which means the f is gonna be a concave up. Because if the gradient of the parabola, the first derivative is positive, then the cubic graph f is concave up. Therefore f is concave up at x equal to 0. So this is the last question. He said draw a rough sketch of the graph of y is equal to f of x if f of 0 greater than 0, which means the y-intercept positive, greater than 0 mean positive. So y-intercept must be a positive because y-intercept x value is equal to 0. So y-intercept must be positive. So we don't need to write the actual y value, but must remember we need to draw the rough sketch, but the y-intercept must be positive. This is a happy parabola. So the graph gonna be a positive graph, cubic graph. So start sad and smile. So the end gonna be smile. So I need to draw a rough sketch. The y-intercept must be a positive. So I'm gonna draw the sketch now. So the sad parabola first, and y-intercept is positive, and there we go. I draw my rough sketch. So the x value is -3 here. First turning point, second turning point, x value is +1, and this is the y-intercept positive, and here I say my x value is negative, here -1, because this is a point of inflection. So this is my graph of f. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.